So today we are going to perform the acid catalysis of pinacol.
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 Okay. Pina colada.
Yeah. So first we have to know what we need. We need a Hickman head, Hickman steel head with a side port.
With a side port. It's a Hickman head. Got it.
Head with a side port.
The side port.
We need a condenser.
Condenser?
Yeah. That's what is called a thermometer adapter.
Is it a little neoprene adapter on top? Neoprene?
No, on the top.
That's neoprene, isn't it?
No, that's a septum.
It's a septum. Okay.
That's a septum with a hole.
Okay, so it's kind of a rubber type septum.
Yeah.
Yeah, got it.
Yeah.
Let me see it. So you can put the thermometer through it.
Through the septum, yeah.
And then you can monitor the temperature underneath.
Yeah. 5 milliliter conical flask.
Is that
1 to 5? That's 5 milliliter one.
Yeah, it's a 5
Conical.
milliliter conical flask.
Yeah.
Okay.
Yeah. So we need 3 molar sulfuric acid.
3 molar sulfuric acid. Okay.
H2SO4.
H2SO4.
Yeah.
Sulfuric acid. Got it.
We need pinacol.
Pinacol, which is pinnacle. Okay.
Yeah, we'll speak about that in the book.
And we'll look at the chemical structure on the board in a few minutes, but they can Google it right now if they want. Pinnacle. Got it. Okay.
Yeah. So we're also going to need a drying agent. In this case, that will be sodium sulfate anhydrous.
So we're going to use sodium sulfate anhydrous as a drying agent for the aqueous workup, I guess, that we'll be doing. Okay.
We are going to need some boiling chips too.
A couple little boiling chips, and those are the little ceramic things that prevent overflow to boiling, I guess. Or you drop them in so it boils nicely. Yeah, it's it makes a nice boiling.
Yeah.
Okay.
So let's go to the board.
Let's go to the board.
Let's speak about the structure. Call that here pinacol.
Pinnacle.
But if you are taking a Dr. Anderson class, you have to know the name according to IUPAC, which means 2,3-dimethyl butane diol.
Yeah. Now, however, those are that's in the alcohol chapter, which is a couple chapters away from the organic lecture. But yeah, that's a great name for it.
That's a common name, and
methyl.
that's also a good review for the nomenclature.
Yeah, and the short name is pinnacle.
Yeah.
P-I-N-A.
Common name here, and the name according to the IUPAC.
IUPAC name. Cool. Okay. Very nice.
Yeah. Now we are going first to fill the conical flask. So we need to go to the balance, which is
so we're gonna
that's pinacol.
measure some pinnacle.
Yeah.
It's a solid, right?
Yeah, it's a solid. Solid, as you can see here.
Yeah.
Pinacol.
Okay.
Yeah.
Cool. A lot of alcohols are liquids, but that's a weird one because it's a
As you see on the bottle.
the dialcohol. Yeah, like ethanol, propanol, butanol. Almost every alcohol I know is a liquid.
Yeah.
This one's a weird solid.
Yeah. So we hope that what you have here is really pinacol.
I hope
That's
so
a
too.
hope. We need 0.75.
You can only hope.
Yeah.
0.75?
Yeah.
Almost a little over. 0.7. They're on the cusp. Uh-oh. 7.4. We're close now. There we go.
Okay.
Let me see it.
Yeah.
Yeah, it's a weird white solid.
Yeah.
It looks like sugar, actually.
Yeah.
I guess sucrose is a alcohol. And a lot of alcohols.
Yeah, a lot of alcohol.
And it actually looks kind of the same way.
Yeah.
So table sugar or normal sugar.
Yeah, we need that. I'm going to add here.
All right, you dump it in.
I'm also going to add the boiling chip. Boiling chip is basically a boiling stone.
Yeah.
But because it's so small, we call that boiling chips.
It's a porous surface. It's like a bunch of little tiny holes.
Yeah.
And they cause bubbling.
Yeah.
And yeah, so that little thing kind of prevents out of control boiling.
Yeah. So let's first add some holes here. It's always water in at the bottom.
Yeah.
And out.
Watch out! Don't drop it.
Oh yeah. And out.
At the top.
In. Come on. Out at the top.
So you put the hose in the bottom because the problem is if you put the hose in at the top, like the water go in from the top, it just pours straight down.
Yeah.
So if you put the water in from the bottom, it fills it up. It's actually
so
basic physics there.
See, it was sitting like that.
Let me see. Let's see the whole thing. Okay, so there's you have the Hickman still at the bottom and the condenser up top, and you're going to flow the water in from the bottom up to the top. Yeah.
We need a thermometer adapter, which is here.
Thermometer adapter.
Thermometer.
Are we using mercury thermometers? No.
No. It's in your research lab, yes, but
yeah.
Here I don't think it's good.
Yeah. In the old days, we'd always use mercury thermometers, but they, the mercury's toxic.
They know. No.
They know about that. Hopefully they know. Now they know. The red alcohol thermometers are less toxic. Okay, so you're going to clamp it up?
Yeah, I need to clamp that. Clean that up. It's better to clamp the condenser. Because the Hickman head is fragile.
Very fragile, yeah. Expensive.
And expensive too.
Yeah, so, but those little clippy thing, or the little plastic things hold it. So it shouldn't fall, but you never know.
Yeah.
You still got to be a little careful. Pop on the thermometer, adapter.
So, and now I will show you how the setting should look like. That's the setting here. Take a picture of that.
And we have the conical vial, but that's an empty one, right?
Yeah, it's an empty one.
Okay,
just
so
show them the setting.
Yeah, just the apparatus. Yep, that's the whole thing. Temperature thermometer, thermometer adapter, condenser, Hickman head, and the conical flask, the conical vial flask.
Yeah.
Okay.
So
you're going to put the water onto the bottom hose, right?
Yeah.
Cool.
Open that.
Very gently, because it might shoot out.
Because I don't want to baptize you, huh?
I don't want
to do that.
Don't baptize me. And we see water.
Yeah.
We see the gift of water.
In at the bottom. out at the top.
And yeah, and just to be clear, why do you do that? Because if you pump water in from the bottom, it will fill up.
Yeah.
And then go out the top. If you put water from the top, it just shoots down,
Yeah.
and then it doesn't really coat the inside of the condenser very well. So
Yeah.
this is just a general trick with condensers.
Yeah.
You get a little leaking going on there.
Oh,
That's okay.
you know, we try to fix that.
We try to fix
But,
that.
So,
I think the student lab fees are gonna
yeah.
eventually fix the
Yeah.
faucets and stuff. I don't know. Okay.
Actually, I'm the one who put this one here
You put
in
some
the past,
tape?
but I don't think it's working very well.
So we a little bit of tape. That's
Yeah.
it's not really holding too well, huh?
Yeah.
Okay, but that's our apparatus. All right.
Yeah. Now, you see the pinacol vice is in a beaker. That's to avoid technical mistakes.
So it's
Because if you leave that alone like that,
Yeah.
that may fail.
you might bump it.
Yeah, you don't want that.
So it'll hold up in a beaker. Good
Yeah.
idea.
So, and you need to add 2 milliliter of trimolar, 2 milliliter of trimolar sulfuric acid.
So that'll help cause the reaction, I guess. It's
Yeah.
a acid catalyst or something.
Yeah. So, then you are going to use a pure range. As I've already said, people should say thanks to you. You are the one who brought that here.
Yeah.
Let's open that.
Don't drop that all over yourself.
Yeah. So,
Strong acid.
yeah, it's a very strong acid. 2 milliliter with a pure range.
So you plunge it up, 2 mils.
Until 2.
There we go, that's 2 mils. And that's about the maximum you can fit in a plunge, right?
Yeah.
You can't do 3 mils in a plunge,
No.
just because of the size of the pipette. You added it already?
Already?
Let's see it. Okay, is it dissolved? It looked like it, or is
Once it become
heated?
yeah, that's
So there's a little bit of a white thing. That's some of the pinnacle, right?
Yeah.
And then the acid's kind of on the bottom?
Yeah.
Okay, cool.
So I put that back here.
Back
I
in
need
the
to
beaker.
close that.
Yeah.
It's very important. Put that on the side. Now I'm going to put that at the bottom. Okay. So now,
You like cook it up, huh?
yeah.
So get the sand.
I should bring that up a little.
Yeah.
Now that has to go to 100 degrees Celsius.
Do you make a little? Sometimes I make a little mountain of sand around it.
Yeah, I need to put that correctly. See,
yeah.
this one has to be here like that.
Drop the thermometer in there.
Yeah, that's how it's supposed to be.
So the thermometer is kind of deep in there, and
Yeah.
it gets that lower temperature as a Okay.
So now we just wait.
So is it on? You turned it on, yeah.
I turned that on, yeah.
Okay. So we can feel, is it getting hot? Yeah. It's gonna take a second.
Yeah.
Ooh,
No,
hot.
I started hitting.
Ow!
Be careful.
Ouch! All right. I gotta go to the emergency room. Ow. Let's see if it burns it a bit. No, it's fine.
So
I should have listened to you.
yeah. Now we just wait. We are going to collect liquid here,
Yeah.
and we'll be transferring that. We need 1 milliliter.
So is that, will be that the product, or is that, what is,
That will be the product and
Yeah.
water.
so
Product and water.
Product and
Because we
water.
have H2SO4,
Yeah.
so H2SO4 will basically
Cause a reaction.
cause reaction, yeah.
And then the product will boil up
Yeah.
and then be captured in that little bulby area
Yeah, and that's why you
right
need,
there. Along with water.
you need a,
The Hickman thing.
a Hickman head with a side pot.
And with the side port, you can suck it out.
Yeah, with side pot with a pipette or a syringe,
You can pull
and
it
then
out.
you can pull it out. Yeah,
Very nice. All right, that makes sense. All right, so now we wait a while.
yeah.
And the boiling chip will just prevent out of control boiling.
Yeah.
Okay. Alright. Alright, so it's cooking a bit, and we can actually see the motion of the fluids. So a little bit of boiling actually too. That's pretty cool.
Mm-hmm.
Come see it here.
Mm-hmm. Yeah. Yeah.
This is the reaction's going. You can see the boiling chip jumping around.
And
that's going to prevent the boiling from going
and with a high temperature, the pinacol will dissolve.
Okay. I might try to touch it again.
No.
Okay.
I think you need your fingers.
Yeah.
You don't want to leave your student alone, because so.
Okay.
After this one, you just have one experiment.
Sweet.
Yeah.
All right. Yeah, reaction's going. It's boiling.
Yeah.
It's pretty cool to watch.
Yeah. Nice part will be the mechanism.
Yeah, the mechanism.
I will speak about
that's a cool mechanism.
the board, yeah.
It's a boiling.
Yeah.
No evidence of product yet.
No, not yet.
And the temperature on the thermometer, what does it say? It says 35? Yeah, I think it's 35.
Yeah, 35.
So that shows that where the thermometer is, it's not experiencing the high temperature yet.
No.
Or like boiling product.
See, the boiling is going very well.
Yeah.
Only problem we may have is that we are assuming that we have the right compound.
Yeah, the stock room has been known to
Yeah.
mess up, so hopefully this isn't like dynamite or something.
Yeah.
Trinitrotoluene.
Yes.
TNT.
Oh.
But it's so far no explosion, so that's good.
Yeah.
And it seems like it's boiling like crazy now.
Yeah.
And eventually the product's going to boil up to the Hickman.
Yeah.
And then we'll see the temperature rise also. What's the temperature at? The temperature is rising a bit. It's at 60 almost. It's climbing. Getting about 65. And I think it's around 70 now.
Start to see some liquid.
I see a little bit of liquid climbing into the. It's almost it's getting up there.
Yeah. Yeah, you have some.
I see some condensation climbing almost.
Yeah.
Temperature is 80. Almost 80 now.
Yeah. Yeah.
The liquid's climbing slowly.
It's more of a same process.
Yeah.
Boiling, vaporizing, condensing, collecting.
Collecting.
Yeah. some coming.
Yeah, it looks like there's a little bit of liquid there now.
Yeah.
It's coming. Yeah, there's more coming. Temperature is about 85 now.
Yeah, I said to go to 100, huh?
About 100 or so, yeah.
All the pinacol has to dissolve too, so.
Yeah.
So students will do appreciate the way we do that.
Yeah, I definitely see product up top now.
Yeah,
it's kind of sinking down there a bit.
Yeah. And the temperature now is about 87, something like that.
87 to 90-ish, almost 90. Yeah, 87, 88.
Once it does reach 100 degrees,
You stop it?
yeah,
Okay.
we leave a little to have more
Yeah.
liquid here.
Cool. So there's your new product. They made a new molecule, huh?
Yeah. You go basically from a diol to a ketone. Huh?
Diol to ketone.
Yeah.
Yes, to ketone, that's right. With a cool mechanism. They're slowly learning mechanisms in class, so.
3 steps.
Yeah.
I will do them on the board.
Good.
Yeah, it's coming, it's condensing well.
Yeah, there's a lot of stuff up there.
Yeah.
It's cool. Go check.
Yeah. Yeah, good. Uh-huh. Yeah.
And what's the purpose of the condenser again? Up top, it's like the water.
If you don't have, you know, when you distill,
Yeah.
you have boiling,
Yeah.
vaporizing, condensing. If
Yeah.
you don't have a condenser,
Yeah.
okay, you are not going to have any condensation. That means that you are not going to collect anything.
It's just gonna vaporize and
Yeah.
it would just sneak out the top. It would go,
Yeah.
it would go out. So the
Yeah.
cold surface up here, I can touch this.
Yeah, touch that, not
Ooh,
below.
not that. And but that's nice and cold.
Yeah.
So when the vapors climb up, you
Yeah.
touch the cold surface and they.
Yeah.
Cool. What's our temperature now? It's
temperature
90
is
something, 92.
92, yeah. The reaction is
That's great.
working, it's great, yeah.
No problem.
But to get, maybe you get that from the syringe. These syringes are too small.
Is that, so you're getting a syringe ready to suck it up, or what's the syringe for?
Yeah, I will use a pasteur pipette.
Pasteur pipette, that'll work.
Better, yeah. This one will be better.
That's to suck up the product out the little port,
Yes.
the portal.
except acetone, other ketone do not smell good.
Yeah.
Ketone, they
Yeah,
have bad smell.
I love the smell of acetone.
Yeah, acetone does.
Acetone's pretty cool. Acetophenone, no, not really. 2-butyl, or is it methyl ethyl ketone?
Yeah.
That's okay, that's like acetone. But this is a ketone too.
That's
so,
a ketone.
Yeah.
Almost there.
It's cool. It's like little mini explosions of the boiling chip as it heats, and then the product's there. Temperature is actually 100 right now.
Yeah. And you have, as you can see, you have,
Tons of product.
yeah,
100% yield. No, I don't know. We'll find out.
100% yield. I have read some publication where people say 100%. That's not correct. I think if you do very well,
Yeah.
usually that has to be between 90 and 95.
Yeah.
And that's also, it doesn't happen very often.
They say 100, they're a dirty liar.
Yeah, yeah.
We're happy with 50 or 60
Yeah.
usually.
Usually when you have 50, that's good.
As long as it's pure, you make something that's pure,
Yeah.
the yield is really not that
There
big.
is no way you can have 100% yield because
Yeah.
each time
Yeah.
you need to purify
Yeah.
at each step,
Yeah.
especially with the experiment you are doing. I'm also doing
Yeah.
this experiment. And whenever you purify, you are going to lose some
That's right.
material.
Yeah. Let's check the temperature again. So basically holding, it's actually wiggling around 100. It goes up and down and up and down and up and down. That's pretty cool.
Yeah.
It's
I
like,
think that now we can
stop it?
stop it
Alright.
because I think we have enough for there. Let's wait 1 minute. And then we stop
One more
it.
minute.
Yeah, 1 more minute.
Get all that product up there.
Yeah. And you see condensation, we collect a lot here. You see what condensation process.
Yeah.
It's a cool experiment.
Yeah, it is cool. It's actually, I like it because you're actually making a new molecule.
Yeah.
The mechanism's pretty fun. They should be able to understand the mechanism because they know something about mechanisms. They're not experts yet, but it is a followable mechanism for them, and yeah, that's really cool.
So we can stop.
We're gonna stop it.
Okay.
Okay, let me get the final temperature one more time. Let's look for it.
100 degrees Celsius.
Sorry, let me look for it. There it is. Yeah, we're stopping at 100.
Yeah.
We waited a couple minutes.
Yeah.
And I think we're ready. We have a lot of products. Okay,
Yeah.
let's stop it. You're gonna unplug it, or
Yeah, first thing to do is to stop that.
turn off the
Unplug
switch.
here.
Unplug.
And you unplug here.
Okay, so 3 steps.
Yeah.
Okay.
So now you have a Pasteur pipette.
So you get your Pasteur
Pasteur pipette.
pipette, and you're gonna suck it out the side portal, huh?
Yeah.
Let me get a good view.
And the side port.
Where are you putting it? Into
that.
the other conical? Let me see.
Yeah, yeah.
Sorry. Okay, so
Put that here.
alright, and the next one. Alright, just gonna get all that liquid as much as you can.
Yeah, as much as I can. I don't think we have too much there left. Okay. So.
Okay. Maybe get it out of the sand, or what do you want to do? Does it matter?
Yeah. No, you can get it out of the sand, no problem.
Just to kind of
Like
stop,
that, yeah.
let all that cool down
but
now.
I'll leave the water on for
And leave the
right
water
now.
on now. But that's gonna.
Nothing can happen now.
Nothing can happen. It'll just start cooling down.
You see the smell? The smell is not good, eh?
Let me smell it. Can you smell it?
Yeah.
The video?
Mm-hmm.
No, they can't smell it. Oh, it's got a weird smell.
And you can see 2 layers.
It's 2 layers, so maybe a top
and what
and
we need the organic layer,
which is maybe the top, I think.
which is the top layer.
That's my guess. Yeah, because usually, unless it's chlorinated, it's usually on top.
Yeah.
Okay, cool. All right.
So we are going to add 1 milliliter of water. Yes, de-water here, already prepared.
Deionized water.
Yeah, 1 milliliter of that.
So this little thing is kind of like a mini separatory funnel. It's like a, that's the way to think about it. It's like a separatory funnel is a nice thing, but it's huge, and they only have a tiny bit of product.
Yeah.
So this acts like a way to separate an organic from a aqueous, and it's microscale. It's called a microscale.
Yeah.
Conical vial is like a microscale separatory funnel. So just like they saw their separatory funnels in the previous experiments,
Yeah.
they got that little guy.
See,
We have 2 layers. But with a separatory funnel, you got a drain at the bottom.
yeah.
With this, you just
Well, when you do
suck
that,
it up
Yeah.
with a pipette.
You have this one here. That we do like that.
You're sucking out the bottom, right?
Yeah.
Which is the water.
Put that to the bottom like that,
Let's see.
and
One sec.
you pull that.
That's kind of like draining out the bottom of a separatory funnel.
Yes, exactly.
Yeah.
So now you are going to add 1 milliliter here.
Yeah.
I prepared the. So now you just have an organic layer.
That's just the organic, because you
Yeah.
sucked up the bottom, which is water.
But
Okay.
I need to wash that again with water. I use a small wrench, and I add that here. Nothing will come here. This wrench doesn't seem to be good.
Is it working? I don't see any water in
I
there.
don't see any. The syringe seems not to be good.
It's kaput. Broken.
Let me try something.
Yeah, get rid of that needle.
Yeah. We have something here, but that's not too. Yeah, we have
That works now. Okay.
Works.
Faulty equipment, nothing works.
Yeah. But I have to be quick.
Yeah. Okay, so how much did you add?
1 milliliter.
Okay, so now we have it's almost like a little mini separatory funnel with aqueous on the bottom
Yeah.
and organic on top. So the organic's on top, the aqueous is on the bottom, and if we want to suck up the bottom, we just use a pipette.
Pipette, yeah.
Yeah, okay,
As I did.
as you did.
So we are going back to here.
Hold on to it so it doesn't fall.
Just to avoid technical mistakes.
Yeah,
You don't want the bottom layer.
yeah.
You want the top layer.
We want the top, which is the organic, yeah.
Yeah. So I put that back here,
Yeah.
and the same process, like that. And as you were saying, you go at the bottom like
Just gotta
that.
see it better.
Yeah. You put the pipette, okay, it goes to the bottom.
Yep. And then you want to
And
suck
then,
out.
yeah, you suck out.
There we see it.
First one.
Yeah.
This one.
You get to the interface.
The second one.
There's a little bit more in there. I see a little bit at the bottom.
You have a little more at the bottom, but that's not a problem because we don't have enough product.
Yeah.
The drying agent will take care of that.
The drying agent will take care of that.
Yeah.
Okay, cool. Okay, yeah.
So, we go back here, and what we do, we add some drying agent.
And you're using sodium sulfate anhydrous?
Sodium sulfate anhydrous. Which is that?
Na2SO4.
Yeah.
Yeah. Another white solid.
Yeah.
That's going to sort of absorb that water.
Yeah.
At the bottom. Smush it up.
Yeah.
Agitate it with a spatula a bit, and that'll make sure it's all dried up and all the water gets absorbed into the salt. Okay.
Gone.
Very good.
You can leave that here like that. So now you are going to collect that here in this vial, but we need the weight of this vial.
So we gotta tear the vial.
Yeah.
Okay.
To do that.
Alright. So you can get it was zeroed, and now the mass of the vial and the cap is 90 what? 6.8?
9.69.
9.69.
Right.
So about a little more than 9.5 grams. 9.69.
Yeah.
Okay. 9.69.
9.69 empty vial. Okay.
Okay.
So
chair weight.
yeah. Now I will do the same. I need to put that into a small beaker.
Get a fresh beaker to hold it up so it doesn't fall.
That's just to avoid technical mistakes.
Yeah.
Put that and prevent that to fail.
Good idea.
Okay. So at this time you need the different pasta pipettes. The clean one, and open that. Now that.
Let me see it. So you got the product with the salt, with the sodium sulfate.
Like that.
You're kind of tilting it a bit just to get that product out and put it into the other vial. So you're getting the product out.
Okay, it's all gone.
So you got most of the product.
Yeah.
A little bit left behind. That's probably okay.
Yeah. Because we don't want some salt. Okay, that's
Very
done.
cool. So that should be semi-pure product, right?
And then
What does it look like? Let's look at it. Oh, you want to cap it?
yeah.
We can inspect it.
That's our product here.
So that should be relatively pure. It's crude, but probably pretty clean. It looks like a nice
That's our ketone.
ketone, yeah. Let me smell it again.
You want to smell
I gotta
that?
smell it.
It doesn't smell good, eh?
Oh! Ay,
I told you it's stinky.
It's stinky. I don't know how to... It smells like burnt rubber, kind of.
Yeah. So now,
But
so you have 0. 9.85.
9.85. Cool. Okay.
Yeah.
So that's 100 megs or 200 or...
Yeah. 9.85.
9.85.
9.69. It's 0.16 every 160 milligram of product.
Sorry,
right here.
0.16, 160 milligrams.
Yeah.
Cool, almost
That's
200,
product, yeah.
200 milligrams, yeah. Very nice.
Yeah.
Cool. It's got a weird smell. It's
I don't smell that.
Don't smell it, okay.
Yeah, you have 3 steps. Step 1. Which is the activation of pinacol.
Activation of pinacol.
Yeah. So you add, and I will write ch234 as it is in reality, it's like that.
H2SO4, sulfuric acid. Strong acid.
Very strong acid, like that.
Don't touch that one.
No.
And you got
So,
two acidic protons.
yeah. So now, what will happen will be the following. I need to write this one correctly. I write that like that. One here and one here. Okay. More pen. This one. But this proton here. That. And this one goes back to the oxygen.
So yeah, got it.
Yeah. Grab that, and this one goes back to the oxygen.
Yeah.
So now,
so you your
no first space here.
That's fine. Just fit it in.
I will go right here. What we have now is the following.
So you protonated your pinnacle.
Yeah. This one here. Now you have that, and here you have that.
Yep, that looks right.
You have
Good.
a push charge here, and you have that.
Protonated pinnacle.
Okay. So plus. Minus charge here.
All right, so good. Now we have a extra proton on pinnacle, and we have an OH2 plus, right? It's a plus charge.
Yeah.
Good. Okay.
Now, step 2.
Yep.
Formation of the carbocation.
Formation of carbocation.
I will write this one again here.
Yeah. Looks good. All right. So where you redrew that, yeah.
I need to do that.
Yep.
So now that's easy. This one just goes like that.
This goes up, and the water goes away.
Water better way.
So it's like water is a leaving group.
Yeah. don't have enough space here.
You can go downward. Maybe down to, just go down or something.
Okay.
Yeah.
Yeah.
Yeah. Cool. And they should know what kind of carbocation that is. It looks like is it a primary, a secondary, or tertiary? It looks like a, maybe it's a tertiary, because that carbocation has 3 things on it.
It's
a tertiary.
It's a tertiary carbocation. Yeah.
Tertiary carbocation.
Yeah.
Okay, so very cool.
That's
yeah.
And water.
And water, yeah.
No. Third step.
Step 3.
Yeah. Rearrangement.
Yeah. And they, at least in our current organic lecture, they haven't done this yet, but they will do it soon. I think next chapter, the chapter after. This is a really cool thing that carbocations do.
So, I will do that again here. This time I will do that like that. Yeah, start. Okay, so what happened now? This one comes over here like that. Okay, and this one goes here. This one comes down.
Yeah.
And this one goes over there.
So it actually, the methyl migrates. It looks like the one of those left methyls jumps
here
to the other side.
That
Yeah.
down here.
Yeah, that's pretty cool.
And what we have, here you have discharge. Okay. So now you have that.
Yep.
That's what you have. And now the last step, which is supposed to be an easy step.
Yeah, just loss of proton, I think.
Yeah. Yeah, last step. Which is also an important one.
That's what we call the 4th step, step 4.
Yeah, fourth step. Step 4.
Be the loss of the proton to make the ketone.
So, yeah, that. And here you have H2O. And this time we do water like that.
Sure.
Okay. Now comes back this one here. And this one goes back here.
And that, yeah. If we gave it a name, that might be deprotonation maybe for step 4.
Oh, yeah,
Deprotonation.
Deprotonation. That.
Yeah.
And now,
You make your final product,
yeah.
which smells well, I would say it's not the stinkiest thing in the world, but it it's not pleasant.
Yeah.
It's not what I would, you know, I wouldn't, yeah.
And this one,
It's kind of weird.
that's the product. Don't forget, you have your plus H3O plus.
Yeah.
Okay. And we should not forget, we still have this guy here. We still have that. H04 minus. That will take care of that.
HSO4 minus, yeah.
Yeah. HSO4 minus will take care of that.
Make the ketone a little, oh, never mind, they can see it. The double bond's a little hard to see, but I can see it.
Here?
Yeah, make a big, better 2 lines.
Okay.
There we go.
Yeah.
Very nice, okay.
So now, you can ask them to give a name of that. When you count here, you cannot start from here.
Yeah.
You have to start from here. Okay? So, it's 1, 2, 3. Okay? That means 3 dimethyl. Okay? 2 butanol.
3,3-dimethyl 2-butanone.
Yeah.
And butanone why butanone? Because it's 4 carbons on the main chain.
Yeah.
Butanone.
But it's also called, as we did at the beginning, it's also called pinacol.
Pinacolone.
Yeah, I will first. Yeah.
That's a weird name.
That's 3 dimethyl
3,3-dimethyl
2
2
butanol.
Yeah. Now, and formally, the naming of those is done in organic too.
Yeah.
But this is a good introduction to the naming of ketones. Yeah, 3,3-dimethyl.
According to IUPAC,
Yeah.
but common name is also called pinacolone.
Pinacolone. That's all of these funny names, huh? Pinacolone.
That's the name.
Okay.
Yeah.
Yeah.
According to IUPAC,
Very
common
cool.
name.
Okay. So I'll add a couple things. Where's the pen talk? One thing, it might be useful just to do the numbering. Just say, well, that's carbon number 1, 2, 3, 4, so they can see how we did the numbering. And you know, this is technically organic 2 stuff. But how do we get to the 3,3-dimethyl 2-butanone? For these ketones, we start by, you find the longest chain that contains the ketone and closest to the ketone.
Yeah.
That's why we go left to right, not right to left.
Yes.
And that's why it becomes a 2-butanone. And then we add the substituents later. 3,3-dimethyl 2-butanone. So that's the full name. The only other thing that I was going to add, looking at the rearrangement, the question might be, why does it do that? Why doesn't it just, I don't know, I mean, what's the motivation for the methyl to jump? And the explanation that I have is that this actually is this has some extra stability.
Yeah.
I call it a RSCC for a resonance stabilized carbocation, because this is actually a carbocation itself.
Yeah.
And you can draw a resonance structure. I'll just draw it downward, I guess. Where this goes up, so like that, and it is actually a carbocation, right? So it's H3C COH CH3 CH3 with a plus charge. And RSCCs, resonance stabilized carbocations, are very stable.
Usually you have rearrangement.
Yeah.
When you have a tertiary carbon,
yeah,
as a carbocation as you see here.
Yeah.
But In this case, we have a tertiary carbocation,
Yeah.
okay? But we also have that,
And the
which is more,
oxygen.
and the oxygen,
Yeah.
which is more stable. That's why you have
Yeah.
this resonance here.
So when they make this thing, I'll make the plus charge a little better there. C plus charge. What you're making is something very stable.
Yeah.
A resonance stabilized carbocation. And the carbocation you see right there,
And
yeah.
correctly the carbon here.
And which one? Oh yeah, let's draw that a little better.
Yeah.
A little hard to draw. CH3. And now there you go. That is I think why it happens. Why does the rearrangement happen? Because you're forming a very stabilized species.
Yeah.